All right, we are going to keep working with our solving stuff today. So we're going to remember some things. We're going to go through some things. We're going to practice some things. So we're going to start by solving with factoring, which we guaranteed have done before. So let's take a look at this first one where we have our 75x squared plus 35x minus 10 set equal to 0. We are trying to solve, which means we want to get all the way down to an x equals. You may have more than one.
Isn't there a greatest common factor?
There is a greatest common factor in this one. We have a greatest common factor of 5. So before I do anything else, we want to take that out. It's going to make our lives way easier. So if I take out my greatest common factor of 5, that's going to leave us with 75 divided by 5 gives us 15x squared plus our 7x minus 2. And that's still equal to 0. Then we want to try and factor this guy. We want to try and factor this piece. So you can use the x, you can use the box, you can use split the middle, you can use bottoms up, you can use any number of techniques. I don't care how we factor, just that we factor. Just be careful because we need to make sure if I was to re-multiply it out that we would wind up with our 15x squared, not 1x squared. So I tend to do this with our factoring by grouping. I'm going to use my a times c, 15 times negative 2 to think about negative 30. And a pair of numbers that would multiply to make negative 30 and add to be 7. That's going to be a 10 and negative 3. Multiply to make 30, add to make 7. And this little obnoxious little 5 over here, he's just going to sit out of the way. I'm not going to do anything with him. He's just going to sit out there. So all these pieces we have in here are going to be the same. Our 15x squared. I'm just going to split apart my 7 into my minus 3x and my plus 10x. And then we have our minus 2. Did I make that really small? I did kind of make that really small. Equals 0. Sorry, I'll make it bigger on the next line just because I know I got a little smushed. I like to do it this way just because I am doing factoring by grouping. If you want to use the box, again, it does not matter to me how we factor, just that we factor. My 5 is just going to sit out in front. I'm going to go through the whole thing on my factoring by grouping so we can see it. What I have shared between my 15x squared and my 3x is a 3x. And we're going to have left over a 5x minus 1. And shared between our 10x and our minus 2, we have a 2. Nope. We're going to take out a positive 2 because this one's positive. And that will leave us with, again, a 5x minus 1. I'm going to close my parentheses, and I'm going to put my equal 0 because he's still hanging out. That lets me get down to our factored form. Because our factored form is going to have our 5. We're going to have that 5x minus 1. And then we have all of our leftover pieces make their own little factor of our 3x plus 2. So by switching it around into factored form, it is going to make things easier to solve. If we just said solve, you could do this however you want with a quadratic formula. We could try and do this by graphing. It's not particularly pleasant, but you could try. Or we could do this with factoring. Either way is fine. We have lots of choices. But I do think factoring is easiest on this one. You do not have to write out all of these steps. If you can go from here to here, and I know some of our Algebra 2 teachers really stress being able to do that quickly and efficiently. Half the time you're doing it in your head. As long as you can reliably do this, that's okay. Just, make sure we can do that because we're going to have to be able to factor. Once we get it down into factored form, how do I find my solutions? Set them equal to 0. I want this guy set equal to 0, so my 5x minus 1 equals 0. And we need to do our other piece. Oh, that's almost the same color. There we go. We're going to take my 3x plus 2 set equal to 0. We do not need to worry about our, changing that color because it's hard to see. The 5, the coefficient, it's not changing anything. If it had an x, then we would put that to get a root there. But since we did not have a variable with the 5, it's not going to give us a root. It's just giving us a stretch. So what are we going to get for our solution for x down here? Positive 1/5, because we'll add 1 to both sides, divide both sides by 5, and we get x is positive 1/5. What about for this blue one that I have over here? 3x plus 2 equals 0. Negative 2/3. Hopefully vaguely familiar. We've done this before. It's just been a minute. So we're just trying to remember. Very similar vibe on the one on the right. We're going to try and factor it so that we can find our solutions. We're going to get all the way down to our x equals. So again, I checked for a GCF. This one does not have a GCF. So I'm just going to hop straight and I'm going to use my x frame. We need to find a pair of numbers that's going to multiply to make 4 times 14, which is in fact negative 56, and adds to be 1. What pair of numbers do we know is going to multiply to make negative 56 and add to be 1? 8 and 7. Which one's negative? 7, because we needed to add it to be a positive 1, because that's this positive 1 right here. So we can put this, again, you can do it the way I do it, or you can factor however you choose. We just typically need those numbers. I'm going to have my 4x squared minus my 7x plus my 8x minus 14 equals 0. You can put your two pieces here in the opposite order. Just be careful. Make sure we would then pull out a negative sign. This minus 7 and 8 are coming from that x frame. That's where I got them from. I'm just uncombining my like terms. So then I'm going to break these up into pairs so I can factor them out the rest of the way. Shared between our 4x squared and our minus 7x is just an x. And that's going to leave us with 4x minus 7. Shared between our 8x and our minus 14 is just a 2. Leaving us with our 4x minus 7. And then we can get this into our factored form, taking this piece out as its own little baby GCF. We have our 4x minus 7 times x plus 2. So when we're solving by factoring, we have to get it into factored form first. We've got to factor it. I don't care how we factor, but we have to be able to factor. It is super duper important. We need to be able to factor. There are many, 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 many choices. If you do not like the way I do it, check YouTube. There's lots of choices for factoring. So then let's figure out what our solutions are, and that's when we're going to take each of our factors that has a variable and set them equal to 0. So we're going to do our 4x minus 7 set equal to 0. And we're going to do our x plus 2 set equal to 0. That's this guy. So what are we going to get as our solution for this left one? For I have it as green. 7/4. What are we going to get as our solution on this one? -2. So this one gets these two answers. And this one gets these two answers. Okay. Should be hopefully vaguely familiar. Questions on this one? Because I know we've had one on the homework that I've already had a question or two about, and that's ones that look like this. It's okay, we can do this. You have options when we look at one like this. Oh, yep. Going back. Over here. So I just was taking this piece and splitting it out into my two pieces. So I was uncombining my like terms here. So these two pieces didn't change. They just dropped down. And then I'm putting them into groups so I can do my factoring. So I took this whole line and I split this guy into two separate pieces. So it just didn't change these guys. They just dropped down.
But it's just one. Like there's just one X, not two, there's two X's.
Oh, down here?
No, when you split it.
Oh, it's uncombining our like terms. So if I added these guys back together, minus 7x plus 8, I would get 1x. That's what we use the x frame for typically, is we are just splitting apart. It happened over here too. I took my 7x and I split it into 10x and minus 3x. If I add those back together, I get exactly this guy. Okay, it's splitting this apart into two separate pieces so that I have 4 pieces so I can factor. Okay? Yeah, no, totally fine. Ask the questions. If we got them, I guarantee you if you have a question, someone else also has the question. I just need one of you guys to be brave. Okay? Let's take a look at this one. I'm zooming it in so we can see it because I know it's small up here. We've got 5x over x minus 3 plus 4 over x plus 3. And that's set equal to 90 over x squared minus 9. I'll give you a second to write it down.
I feel like we've done this one. At least the denominators.
Say it again, because I didn't hear
I
you.
feel like we've done a problem before with the same denominator.
We probably have done a problem before with the same denominators. We use these ones a lot. Because what is special about this denominator here? It's a difference of squares. This guy is a difference of squares. So I could write this in factored form. What is x squared minus 9 in factored form? X minus 3 and x plus 3. That's our difference of squares. So if we look at this whole equation, since now I have fractions on both sides, I could simplify the left side, get them to a common denominator, and go from there. Other option is I want us to think about what would be the lowest common denominator of all these pieces. X minus 3 and x plus 3. X minus 3, x plus 3. So that would be our common denominator. I could do that and leave everybody in fractions and just combine things together that way. Easier option now that we have equal signs. Because now I can do whatever I want as long as I do it to both sides. Fractions are icky. Multiply by what our denominator should be. Multiply everybody by our lowest common denominator. I'm going to write the whole thing out just so we can see it. You do not have to write the whole thing out. I'm just going to say, so we're going to have our 5x over our x minus 3. And I'm going to times x minus 3, x plus 3. Then I'm going to have my 4 over x plus 3. And we want to multiply this guy also by our x minus 3, x plus 3. Then we have our equals to, and another fraction that had our 90. And this one we factored it down. I'll keep it green here. With our x minus 3, x plus 3. And I'm right at the end of my screen. So there we go. This one we also want to multiply by our x minus 3, x plus 3. There we go. Just trying to make sure y'all can see everything. Yes, dear. Yeah, I'm wearing cuffs. So as long as I do the same thing to both the left side and the right side, I can do anything I want. That includes multiplying by x's. So when we do that, what's going to happen on this first fraction over here? Ooh, that's not lazy pointer. This guy. The x minus 3's cancel out. So this guy is going to go away entirely. What's going to happen on the one with the 4? On this one, our x plus 3's are going to cancel out. What's going to happen on the one with the 90? They all go away. I'm going to zoom this back out just so I have a little bit more space. Ooh. So this guy's going to cancel out this guy, and this guy's going to cancel out that guy. And when I write down just the things that did not cancel out, we wind up with our 5x times x plus 3 plus 4 times x minus 3 equals 90. And that is much, much, much less gross.
Are we going to distribute the 5x and 4?
Uh-huh. We still want to get down to an x equals. We're still trying to solve. So we need to distribute. I take my 5x times both of these pieces. And we need to take our 4 times both of these pieces. So we're going to have a 5x squared. And I'm going to change the view again because I don't like it being down that low. There we go. Or small. Plus our 15x that we get from this distribution. Then we're going to have our 4x minus 12 from that distribution. And then we still have this equals 90. Now what should we do? Combine some like terms. So we're going to have our 5x squared plus 19x minus 12 equals 90.
Equals 0, right?
We have a quadratic here. We have an x squared, which means before I can go any further in trying to solve it, it needs to equal 0. So we've got to subtract this 90 from both sides. Super duper duper important. We need to combine all our pieces and get it set equal to 0. So we're going to have our 5x squared plus 19x minus 102 equals 0. Gross. Because we're still trying to solve this. We want to get down to an x equals. It is factorable. I'm going to show you how to spot it if we don't see it because it's weird. I totally get it. You can also do this with quadratic formula. Totally fine. It is a quadratic. If we were to be trying to set up our x frame to factor here, we don't have any GCF between 5, 19, and 102. We don't have any GCF between 5 and 19 other than 1 anyway, so we don't even have to think about it. But if we do our a times c, 5 times negative 102, we get negative 510. Ew. And our b value is 19. So we need a pair of numbers that multiplies to make 510 and adds to be 19. I don't know the multiples of 510 off my head either. So if we wind up with obnoxiously large numbers, which occasionally happens, I'm going to make a list of factors and not have to try and think it with brute force in my brain. So I'm going to make a list of things that multiply to make 510. Because what we're looking for is a pair of numbers that will have a difference. Because one of them needs to be negative in order to get a negative up here. So we need a pair of numbers that has a difference of 19. So things I know multiply to make 510. Well, 1 and 510 definitely is a pair. 510 is divisible by 2 because I see that it's an even number. So that's going to be 255. Not down to a difference of 19 yet. That's still a pretty big difference. 510 does divide by 3. Because 5 plus 1 is 6. 6 is divisible by 3, so 510 is divisible by 3. And luckily, we have tools at our capacity. We can use them. It'll be 170. Well, that's not helpful either. So I'm going to keep going. It doesn't divide by 4, but it does divide by 5. We got 5 from multiplying 102. Because honestly, that's where it came from. It does divide by 6. And you can do this like in the calculator. Say, okay, 510 divided by 6 would give us an 85. 510 does not divide by 7, gives us a decimal. Does not divide by 8. Does not divide by 9. It does divide by 10 though. What is 510 divided by 10? 51. See, we don't need calculators for all of it. It doesn't divide, I'm going to give you more. It's like it doesn't divide by 11. It doesn't divide by 12. It does not divide by 13. It does not divide by 14. It does divide by 15. 15 and 34. I was like, we could keep going. We can get down and do 17 and 30 and keep looking. We could go through a bunch of them. I think that's actually the last one that does work. Which pair has a difference of 19? 15 and 34. Which one of them needs to be negative? Because we need to wind up with a positive 19. So we're going to have our positive 34, negative 19, 15. So again, unpleasant. We are not going to ask you to do something like factor 510 on a regular basis. Because, ew. This isn't testing anything that we need to like, see, it's testing if we know how to factor, like, we know how to multiply to be 510. I don't like when they do things like this, but they occasionally do, and so I like to throw one of the weird stuff that they do occasionally for us. Again, once we get here, you can factor however works for you. I like to do my factoring by grouping. So here what this does, what our x frame does, is it splits this middle term back into its two pieces from before we combine like terms. So we're going to have our minus 15x, our 34x, and our minus 102. And we're going to put this into its factored form. Breaking it up into pairs. Again, we should not wind up with numbers quite this big on a regular basis. If you're regular getting things up above the like 100, 200 range, go back and double check for greatest common factors because we should not have tons with those high numbers. Occasionally, fine. Every time, no. So I'm pulling out my greatest common factors. My first pair, it's really easy to spot. We've got a 5x, leaving us with x minus 3. And in my second group, it's a little harder to spot. But since we know we're factoring, and these should hopefully be factorable, I know I want to have my leftovers ideally be x minus 3. So let's see if 102 is divisible by 34. Because if we did it right, this should be exactly the same thing here and here. If we factor correctly, those guys will match up. Otherwise, it's not factorable. If it doesn't work, we can't factor it. So our factored form is going to be our x minus 3 and our 5x plus 34. So what are our solutions going to be? We're going to have x equals 3 on this one, and we're going to have x equals negative 34/5. Ew. I was like, if you want that as a decimal, you can. It's negative 6.8. Totally fine. But these are the answers that we get from our factoring. We do need to remember that this came from us multiplying by an x, which means I have got to check it. We've got to go all the way back up to the top. Because if my x equals 3, we wind up with a problem here and here. Because we wind up with a 0 in our denominator. So because we had x's in our denominator, we've got to check it. Because x equals 3 is extraneous. That is not the pen. It's extraneous. So it's not actually a valid solution. O-U-S. Oh my gosh, they made us do all this work and it doesn't even count as an answer? Oh, they're so extra. Oh my God. Ew. Gross. It's so extra. Yeah. So if you put extra, like that's, I am okay with that. I do not care about how we spell extraneous because Lord knows I can't spell extraneous. Spelling is a suggestion. So while we're looking at it, let's double check and make sure this is not going to give us any problems in our denominator. It's rare that we get 2 extraneous solutions, but it can happen. So this guy, remember, this was negative 6.8. Do we get any problems in our denominators if x is negative 6.8? Nope, good to go. This guy's our answer. So this only has one solution. It's our negative 34 fifths, or negative 6.8. Again, genuinely do not care if you put it as a decimal or as a fraction, as long as it's a short decimal. Don't round them off. So if you get thirds, sorry, keep it as a fraction. Okay. Questions on this one? This is definitely our grossest. Definitely our grossest. So when we have our rational type questions, find your common denominator, multiply everybody, and then simplify. Okay, so if we have our equal sign, we can multiply by whatever we want. That includes our denominator. Okay. So there won't be tons like this, but every now and then we'll see these. We'll see these more when we start looking at these in depth. So we're going to shift gears just a smidge to something we may or may not have actually seen before, which is going to be called completing the square.
I feel like
We touched it very briefly, and I pointed a couple things out to you very specifically last year because I knew you wanted to do this. This is one of the things that we did slightly differently last year. So completing the square means I'm trying to make it be our perfect square trinomial. I want to be able to write this as our x plus something squared. I want to be able to write it that way. Our factored form should be exactly the same. X plus 2 times x plus 2. Or x minus 3 times x minus 3. I want it to be perfect square. We are not always handed something that is a perfect square, but I can force it to be so because I'm stubborn. And there's benefits to it, I promise. We'll see why. So for completing the square, when we have the A and the B, the piece that we need on the end, the value that's going to complete this square, they call, in the book, they call it K sometimes. Oh, hello, blinky screen. We take our B, divide it in half, and then square it. That's what the number on the end should be to make this be a perfect square trinomial. So when we have an A value of 1, and we want this to be a perfect square, we're trying to make this factor into the exact same thing. So I'm going to show you why it looks like that. But look at this one. I want to be able to factor this and have it still give me my x squared and my minus 8x, but have it be exactly the same. So I know I need to have the x's in the front. If I wanted this to divide into 2 exactly equal pieces, what would that be? If I wanted to divide minus 8x into two exactly equal pieces? What's negative 8 divided into 2?
4.
4. If I split this into minus 4x and minus 4x, that's what we're thinking about here. It would give us factors that have x minus 4 and x minus 4. I'm going to show you why, I promise, because I know I'm doing things in a weird order. If I was to multiply this back out, seeing how we have our x minus 4 squared, we would have our x squared, our minus 4x, our minus 4x, and what on the end over here? Plus 16. This is exactly the same thing as x squared minus 8x. We're just adding a 16 here to make it be this nice, tidy, perfect square. We're wanting these two pieces to be exactly the same so that I could write it in a factored form that is our x minus 4 squared. These two pieces are equivalent. They mean the same thing. So if we say what value would complete this square, they're asking what number would we add here? And it would be half the middle, because we need to divide it into exactly two equal pieces. And then looking for this guy on the end, it's that number squared. So I'm going to put one in the middle here for us to practice this again, because I kind of worked through it in a very strange order. So I'm going to give us x squared plus 6x plus what? We want to figure that out. So if we think about the little pattern I gave you guys up at the top, what is our b term in this one? 6. What is b divided by 2? 3. What is b divided by 2 then squared? 9. So this is telling us that if we had the equation that was x squared plus 6x plus 9, I could also write that as a perfect square. That's exactly the same as if we had our x plus 3 squared. These two statements are equivalent. Okay? I know it's a super awkward way of thinking about it. Because the book then tosses us straight into fraction-y awfulness. Questions on these two before we look at the second one that is going to be fraction-y? Or the third one? Okay. Let's take a look at the third one, and we're going to approach that one the exact same way we did here. I'm going to start by figuring out what b is. We're going to divide it by 2, and then we're going to square it. So what is our b? 9. What is our b divided by 2? You can do it as a decimal, or you can do it as a fraction. So you can either do it as our 9/2, ew, or we can do it as 9 divided by 2, which is 4.5. Again, it genuinely does not matter. We can do it either way. Then we're going to look for our b over 2 and square it. So we can either take our 9 over 2 and square that. So 9 squared gives us 81. 2 squared gives us 4. Or if you do it as a decimal, absolutely valid. 4.5 squared would give us 20.25. Either way is fine. And I know it's chaotic and weird. What this is saying is if this guy was our 81/4, or if it was 20.25, then it would be our perfect square trinomial. It would be like that. So the value we're looking for at the end is if I had my x squared plus my 9x, and then we had our plus, I'm going to put it as the fraction, 81/4, That is 100% the exact same thing as if we put this in factored form. We would have our x plus 4.5 squared. And again, I could multiply that out and it would 100% work. It's just wording this in a super strange way. So the value that completes the square, what this c would need to be, is the 81/4. So it's just trying to figure out what number goes here in order to make these be perfect square trinomials. And the fraction-y decimal ones are kind of gross. Yes, dear? When a is not 1, it's just slightly weirder because we have to factor the a in on the finding the piece. I think we only give it to you when a is 1. Yeah, I think we're only going to work with it when a is 1, just because completing the square when a is not 1 is genuinely gross. Okay, so we're only going to work with it when a is 1. It is workable. We just have to do other things, and it's not pleasant, and I don't recall it off the top of my head. I know it exists, but I don't recall it off the top of my head. Okay, we're going to practice this some more, I promise, because they will sometimes give us either end and ask us to find the middle, because we are going to use these to solve. I don't know that we're going to get to solving these today. We might solve it tomorrow. Let's see. So this is the same kind of thing. We want to figure out what that middle value would be that's going to give us our x plus something squared as a perfect square trinomial. So if they give us the first piece and the last piece, we know different amounts. We know that this guy is the exact same thing that we had before. Our b, that middle term divided by 2 that we then squared is exactly what this piece is here, our 36. How could I figure out what the b needs to be here? Square root both sides. So we're going to have b over 2 equals or plus or minus 6. It could be a positive 6. It could be a negative 6. Both would work. So what is the b going to need to be? How do we get b by itself? Multiply by 2. So if b is positive or negative 12, this would be a perfect square trinomial. So when we have a 36 on the end, if I want to be able to put this as my x plus something squared, I need that b to be either positive 12 or negative 12. We're going to do the same vibe on the right side, and then we will see why the heck we want to do this and start solving with them tomorrow. Just because I don't want to go and try and speed run one right now. So we know if this is a perfect square trinomial, we're going to have b over 2 squared. That's going to exactly equal our 49/4. If this is a perfect square trinomial, this guy has to follow this pattern. So again, same process that we did on the left one. Start by square rooting. What does b over 2 equal? 7 over 2. Don't forget, when we square root, plus or minus. So what is b going to be? We get all the way down to b. Plus or minus 7. So if we had x squared plus 7x plus 49/4, or x squared minus 7x plus 49/4, that's a perfect square trinomial. And we could put it as an x plus something squared. Okay? We will use these with our solving stuff starting tomorrow. All right, I'm putting up here the numbers for 2-3. It's currently scheduled for due Friday. I just pulled up my IU registrations and checked it. You guys have done really, really good following the instructions in the ACP email. I only have 4 people in both of my classes who have not yet registered. I do not know specifically who those 4 are yet. I have not had the time to go look through the list. Hopefully I should get to that today. So I can, I was gonna say, I was like, I have the list. I can look individually, but I don't have time to cross check because it doesn't sort it by course. Oh, no, it's not you. Yes, Jim.
I have a question on one of the.
I have an answer.
I also just saw the email. I didn't register.
That's totally fine. Yeah.
It was number 4.
Uh-huh.